So today in this session we will see how we can distinguish between the different type of carboxylic acid by using a different type of test. How we can do identifications. So this is we have three solutions. One is acetic acid, second is formic acid, and ethanol. So out of this, how we can distinguish these three? So if you see acetic acid and formic acid, they will react with the sodium bicarbonate to give the effervescence, in which the ethanol will not give you this one. So ethanol is separated. Now how we can separate the formic acid and acetic acid? So formic acid undergoes the reduction with failing solutions and Tollens reagent. So this is also separated, in which the ethanol will not give you the failing solutions and Tollens reagent. Now third is the acetic acid. So it is automatically separated. Second is calcium formate and calcium acetate. How we can identify? So just you heat these two products. So if you heat the calcium acetate, it will give you it will convert into giving the pleasant odor of vapor, so which is nothing but the ester. And if you heat this one, it will give you the pungent odor, which is nothing but the formaldehyde. How will you identify malic acid and fumaric acid? So this is very important compounds. Fumaric acid, these are both are isomers, but one is cis and other is trans. Fumaric is trans isomers. Both are bicarboxylic acid. So it's very easy identifications. If you heat the malic acid, it will convert to malic anhydride. But in case of fumaric acid, which is the trans isomers, it is not heated. You cannot heat it. It cannot be converted to anhydride. This is the basic way to identify the compound. No reaction will take place in this case. Reaction will take place in this case. Now, how will you identify acetic acid and acetone? They are different compounds. So in case of acetic acids, if you use the sodium bicarbonate, they will give you the CO2, and CO2 causes the effervescence. While in case of acetone, so this is the acetone CH3CO. It can undergo hydroform test which acetic acid cannot go. It can also react with the 2,4-DNP compound to form a yellow crystalline substance, in which acetic acid will fail. So these are the different tests to identify the acetone and the acetic acid. Acetic acid and acrylic acid. So acrylic acid, you can see this is the propenoic acid. You can see this is propenoic acid. Propene 2-enoic acid. Second carbon is the double bond. So propene 2-enoic acid. So how we can identify between these two products? So this is the unsaturated carboxylic acid. So it will, due to unsaturation, we will take the test of unsaturation. So it will decolorize the bromine water in CCl4, or it will this double bond will react with the KNO4 to give the purple color. And these two tests is not given by the acetic acid. In this way, we can distinguish these two different compounds. How can we identify the tartaric acid and citric acid? So tartaric acid undergoes the Tollens test, while the citric acid does not. So in this way we can distinguish. So this you can say 2-bromopropanoic acid, and this is the keto acid, which is nothing but the common name is pyruvic acid. So in this case, due to the presence of keto groups, so it can react with the this one 2-DNP, so dinitrophenylhydrazine, and they form the red insoluble precipitate by the pyruvic acid. But in case of this 2-bromopropanoic acid, so they will not give the 2,4-DNP test. So this is the only test which we can distinguish between these two different products. So this is a 2-chloro-propanoic acid, and this is the propanoic acid. So one is the aliphatic, one is the halogenated aliphatic acids. Alpha halogenated, you can see that. So how we can identify? So we will use the silver nitrate test for the each reactions. So in this case, what will happen? If you use the aqueous silver nitrate, so both will give the precipitate. If you use the aqueous silver nitrate, both will give the precipitate. So in case of aqueous silver nitrate, so this will react silver is replaced by the water. Okay, OH. So first it will form the CH3CHO2 hydroxypropanoic acid. The again silver will react with the carboxylic acid to give the CH3COH and COAG. And this AH is replaced by the AG, and this is, you will get the AgCl. Now this is soluble in nitric acid, but this is insoluble product, this white precipitate which is insoluble in nitric acid. This only distinguishes between this one. If you take the propanoic acid, this will also convert into silver precipitate. This also react because H will be replaced by the silver, and since it has no Cl, so this will be fully soluble in nitric acid. The first step is to convert it to silver nitrate, which is soluble in nitric acid. This is the one condition. A second step is, since it has AgCl, AgCl do not dissolve in nitric acid, so it will be remain as a precipitate. So this is the way of identification between this 2-chloropropanoic acid and propanoic acid. This is one of the important tests. Now we have one more compound, is called malonic acid, and this is the oxalic acid. So how we can distinguish? So we can distinguish